This is the guided note video for dotted or solid. The learning target is I can determine when a linear inequality has a dotted or solid line. When dealing with linear inequalities, we no longer have an equal sign. Instead, we have four different signs: greater than, less than, greater than or equal to, and less than or equal to. These signs tell us a great deal about the type of line or solution we will have. It will be very important that we know how a sign can impact our answer. So, all linear inequalities will use either a dotted, some people use the term dash, that's fine too, or a solid line when graphing, depending on whether the line is included or excluded from the solution. A dotted line means the solution is excluded on the line, while a solid line means the solution is included on the line. So this might make no sense to you at all, but how about I erase this, move a little bit further down, and I can explain this a little more in depth. So for our four inequality signs, we have less than, we have greater than, we have less than or equal to, and we have greater than or equal to. Okay? So as I just said above, when we have a dotted line, that means our solution is excluded. So you don't have to write this, but let's say for this less than sign, I were to have x is less than 2. Okay, so this means x could be 1, x could be 0, x could be -5, x could be -257, x could be -4 million. Okay? What I mean by included or excluded, since I have x is less than 2, x can't be 2. Because if I were to plug in a 2 for x, I would have 2 is less than 2, which makes no sense. Okay? So that means our solution, or 2, is excluded. Okay? Therefore, whenever we have a less than sign, our line will be dotted. Similarly, whenever we have a greater than sign, our line will also be dotted. Okay? And if I were to have x is less than or equal to 74, let's say. Okay? This means x could be 73, x could be 72, x could be 9, x could be -2,400,076. Okay? If I were to plug in 74 here, it would read 74 is less than or equal to 74. So 74 is not less than 74, but we also have this line down here, which means or equal to. So we would have 74 is less than or equal to 74, in which case that would be true. So if we were to plug in 74, our solution would be included. So because it would be included, whenever we have a less than or equal to sign, we will have a solid line. And whenever we have a greater than or equal to sign, we will also have a solid line. Okay? So all we really need to do is check the sign in our given problem and determine if the linear inequality will have a dotted or a solid line. So looking at these two examples, what kind of line do the following linear inequalities have? So I have y is greater than or equal to -x plus 1, right down here. So I'll take a look at my sign. It is greater than or equal to, so I know I'll have a solid line. And that is all I'm looking for. Some people remember it by looking at this line down here. Okay, there's a solid line underneath our sign. Therefore, our linear inequality will be solid. Okay, so looking over here at this standard form inequality, we have 5x minus 3y is greater than 12. Okay, so we take a look at our sign. It is greater than. I go up here to my key. Whenever I have a greater than sign, I will have a dotted linear inequality. Therefore, this will be dotted. So this might seem fairly basic. And I think everyone could agree that this is not the most complex thing you've ever done in your entire life. But this will help us break down linear inequalities. Okay, so we're not receiving a bunch of information at once. We're breaking it down into smaller, more manageable parts for us to understand later on. Okay. At this time, I would move on to the dotted or solid practice worksheets.